I'm sure most of you have learned about scientific notation and standard notation, but I'm going to review it with you just a little bit, just to refresh your mind. So, scientific notation came about because scientists and mathematicians didn't want to have to write out really, really large numbers with many, many numbers. So they used what we call scientific notation. It's almost like a shortcut or a shorthand for math numbers. So here's what they've done. Instead of saying 245, for example, well, let me say 245,673,000. Instead of saying that number, which, by the way, what in the world is it? 24,567,300. Instead of saying that, we can just say this. We can take the first number, 2, and then put a decimal, 0.4567300. Now let me show you how I count. So I'm going 1, 2, 3, 4, 5, 6, 7. I went 7 spaces, shall we say. All right, so all you have to do is say this. 2.45673 times 10 to the 7. You don't have to put those zeros in, but you do have to put all these numbers in. All right? Now, if you wanted to check that out, all you have to do is take this into the calculator and type it in, and you'll see that it comes out to 24,500,000 and so forth. All right? All right, let me show you another thing. All right, let's determine how we're going to write this number in scientific notation. All right, so what we have to do is look at the very first digit of whatever the number is, and you then put a decimal, 3.6. And because they're all zeros here, I don't have to put those zeros in. All I do is say times 10. Now I go back up here if I want to, like this, and I'm going to put that decimal right there. 1, 2, 3, 4, 5, 6. All right, so it's times 10 to the 6th power. My first number has to be less than 10. So it has to be either a 1, 2, 3, 4, 5, 6, 7, 8, or 9. It can't be a 10. I can't go 10.7 times 10 to the whatever. I can't do that. I can't go 23 times, 0.1 times 10 to the whatever. The number has to be a single digit in the very front. All right, so let me show you what I mean in a problem. Suppose we have this problem right here. We have 4 times 6.2 times 10 to the 11th. Well, the first thing we have to do is multiply this. So if I multiply 6.2 times 4, I'll just get 2 times 4 is 8. Then 4 times 6 is 24. I look at this decimal here. I move 1 in like this. So my answer so far is 24.8. Well, I just got done telling you you can't have, times 10 to the 11th power. All right, you can't have that. So what we have to do is we have to move this decimal 1 place to the left. Because we move it 1 place to the left, we have to it's almost like an equation. You have to change this, and this has to go 1 place to the right. So we're going to call this 12. So my final answer will be this, 2.48 times 10 to the 12th. That's what that equals. All right? Let me do another one real quick with you. How about if I say 4 times 12 times 10 to the 5th power? Okay? Well, just multiply 4 times 12, and that's 48 times 10 to the 5th power. But there's an automatic decimal there, but I have to move it one place to the left, which means I have to move this guy one place to the right, just the opposite. The final answer will be 4.8 times 10 to the, not the 5th, not the 4th, but to the 6th power. So this goes to the left, this goes to the right. The last thing in this video that I want to talk about is standard notation. So standard just means a regular number. So if I want to turn this little problem into a regular number, I go like this, 5.4, and then I look at this 3, and that tells me that I have to go 3 places after the decimal. So I'm going to go like this, 1, 2, 3, put a decimal. And in these little squiggly deals, I'm going to put zeros. So 5.4 times 10 to the 3rd power turns out to be 5400. This number turns out to be 4.5, and I have to move it 4 places. So 1, 2, 3, 4. And I put in those numbers, so 45,000. And then this just means 5.4, and I'm going to move it 4 places. 1, 2, 3, 4, put a decimal. 0, 0, 0. So this is 54,000. Now, one of the problems on your grad point thing says, put these in order from the smallest to the greatest. Well, to tell you the truth, they're already in the smallest to the greatest. Look, that's the smallest, that's number 1. And then this is the next guy, 2 and 3. Hello, they're already in smallest to greatest. Okay, that's it.